Hello everyone, welcome to my one more new videos. In this video, we are going to discuss about the presentation on final year building project. This is the one of the sample projects, what kind of format you have to include in a project, final year project, and what kind of topic and what kind of data results has been included in your presentations. Your presentation may varies. You can make your presentation uh, differ little bit differ, but this kind of topic you has to be included in a final year project. Let's start the presentations. In the first slide you have to be it the university name, college name, institute of engineering, college name, address, and the college logo. And here is the topic like analysis and design of earthquake resistant multi-story residential buildings. And the next one, the group members you have to include here, and the supervisors name. Second, acknowledgement. Thanks to your supervisor and thankful to your departments. The third one, intro. Introductions. You have to introduce your project at the point wise to similar to discussions in the EG. Uh, Here I'm going to introduce the suddenly release energy in the tectonic plate. That's why I'm going to do some economical, not economical, based on the assessment risks and Indian standard practice in these questions. Like this, you have to introduce your project. Second, next one, the objective. What the objective of your project, like modifications, and also mark bold your later that you have to be focused on just modification, preliminary design, software numerical method modeling, analysis, design, and structure drawing, and the codes like this. You can also pause the videos and read all it that is helpful for you. And the next one, the objective. To follow the next one is scope. To follow the above objective, you have made the some scope of your project like determinations of structures load on the vertical and horizontal, that is estimating of load and based on the shear and vertical distributions equivalent earthquake load in ETABS version, what kind of versions you have used, what kind of software you have used analysis like this, and limit state designs like this. And the next one is the code of the practice. In your project, what kind of code you have practiced for solving or use in the software to calculate or project to completing the project. This may be where I'm going to discuss about the here I'm including the Indian standard, but you have to use your own code on a different code. You have the different codes, what kind of code you have in practice like this. IS 875 part 1 1987 for what the date loading post load for the part 2 like this. You include what kind of code you have practiced. The next, plan elevation sections of the selected architecture drawing. There you have to be also show your plan elevations and sections of the architecture drawing. You have to be selected before starting the project. Like this you have to present. This is how the plans of the lower basement plan and the upper basement plan, ground floors, and the similar you have to be included, or 1 to 42 is similar, that's why it's similar. And the 13 plan is deferred, that's why 14 and masons plans. And the elevations, side elevations, north side, both four side elevations you have to discussions. And the sections you have also present. And the next, the descriptions, the building descriptions. You have selected that building architecture drawing. There are the descriptions, what the name, what is the where the name of your project or the building, locations, building types, structure, systems, building purpose of building, total build up area, plinth area, floor types of foundations you have used, and number of story, floor height, and the types of soil you have here. Medium types assume, that's why. And the seismic load, width, and these kind of topics you have to include a staircase and concrete grade, and the limit dimensions, lift dimensions you have to include it. And the next one, the silent feature of your building, yet fairly regular or not, what kind of wall you have included, the main beam or the column is centrally located or not, any M25 grade or the center line dimension or not, like this, the similar silent features. And the next one, the preliminary design. After you have done the preliminary design, there are the results came. Like RCC slab has uh, depth 130, overall depth 150 mm. After the calculations of preliminary designs, you have only included here the final result only. Okay, no need to show here the preliminary whole calculations here. Already we have discussions on the how can you calculate this preliminary design in the previous video, and also you can follow through the link. in the descriptions, like main beam depth, overall depth, width of the secondary beam, columns, width and depth, and the center of mass and rigidity you have calculated. Each floor you have to be shown center of mass, rigidity, eccentricity, okay, and then you can also check and there, so either all is okay. If not, and then go to the descriptions, link is in the descriptions why not okay. And then next work I have to be base here. There you have not discussions all these things. Here you can only say the base here calculation is for the IS code this and clause this, and you have set the formula and what the value you have be taken, like Z seismic zone factor 0.36, the from the table these, and I from this table with this for the building these types of buildings, and R years and dx and dy, and the seismic load. There the result seismic load you have calculated already in the reports. That's what you are directly you can introduce here. And the next work for the other building and for the RC, because in our buildings the RC structure there is shear wall, the lift and the lots of shear wall. That's why I'm calculated the two types. Here the EV base shear has been calculated on the two-way, you can present like this. And load cases and load combination. What kind of load cases and load combinations used in your software ETAB? Like load cases, the dead load, live load, earthquake load in the x direction, y direction, and the 15 and 14 combinations. The load like 1.5 dead load, 1.5 dead load plus live load, like these, and you can add this like this. And so the presentations is included, so you have considered in your project. That's why the next the ETAB model. After completing the ETAB model, you have you have got this kind of view, 3D view, the ETAB building model, the deformed shape. After deforming, after analysis and design, you have got the deformed shapes like this present. And the third one is, and the next one you have to present is axial force diagrams on 1.5 dead load and dead load plus live load. That is Udican. Yes, to I mean in the name Udican, that means 1.5 times dead load plus live load, and like shear force diagram and bending moment diagrams. And how you can this data, you can take this data from the ETABS and get the screenshot and put it here. I have already discussed in the previous video, you can go through the link. This the bending moment shear force diagram, bending moment diagram is get a screenshot and take from the ETAB. And after final result obtained after all the concrete pass the design check in the ETAB. Here was the result on the slab with thickness 1.5. This is the result after you completing the analysis and design in ETAB. There was all the shape and all the member has been passed. There have been the specific depth of the dimensions of the all the beam column slab, like this slab 150 beam, primary beam, secondary beam, and lift beam. There are the three types of beam I'm using in this project, and the columns and all the dimension is in mm. Okay, the load patterns on the auto seismic code 1893 2016. This is the automatic generated on the seismic load on the EQX in the 19 from the calculated by the ETAB. This is the ETAB data. I have the load pattern design in the auto. This data is taken from the ETAB and also match to our one data. They are quite similar. Take the screenshot from the ETAB and put here. And the next one, check what kind of check you have done in your project. All the check result has been shown here. So what kind of check, the model mass participation, and what kind of check, lots of check. That was on the previous video I'm discussions. All the check like this mass participation, regularity, all the checks has been discussions how you can check and what kind of data you have taken from the link from the previous video. You can check this. And here is the result, the mass participations result. The mass participation is greater than 90. All the checks data has been taken from the ETABS. Okay, the model mass participation greater than 90. Post mode translation in y directions, x direction, z directions in the rotations, and and the mass participation ratio. This here all there you have to join. Here you can seeing that the mass participation 90°. But how you can show the tables? This is the results of the after the 90% cross there. in the bottom. And similarly the regularity and irregularity check on the basis what on the which code you have to follow, which code you have to follow to regulate regularity and irregularity check. Here I'm going to, here is code these, and then what the definitions of regularity and non-regularity you have to discuss, and this all from the codes. I'm not writing this all the points have been come from the codes you can put in your project. And the torsional irregularity, the first irregularity check are torsional irregularity check in the clause table 1.5. This has been discussions, and what the torsional irregularity uh, says. This is the lateral force and the 1.5 times the minimum the horizontal displacement farther in the same floor. And here the result, all the stories have been found to be torsionally irregular from the load cases EQX and EQY. That means del x is less than 1.5 del x. You have to say this is the result. But you can also show the, this is the past result, and you can also show your this torsionally irregularity check data from the tables. ETABS, you can get the screenshot of this. And the next, and this is the check, irregularity check and regularity check. Here the torsionally irregular, all the floor has been torsionally irregular. You have show the result because you have here you can write, here you can write torsionally irregular. What happened? Here you can write the torsionally irregular and the all the torsionally irregular, and you have also show the results. This is about the result. Here from there you can take the data like this and you can check. The third, on the y-axis you can also take the torsional irregular. And the third is vertical regularity check. Vertical stiffness, the soft story check. And the soft story check, what the soft story means you have to write. And the result, the all the story has been regular. Ki is greater than 0.7, ki plus 1, and here is the results from the ETABS we are calculating, and there is the form regular, came regular. And the mass regularity check, the mass regularity check, mass regularity definitions, and the result has been passed, and show the result like this. This is in the mass regularity check is a pass. Similarly for the vertical geometry means what the geometry means, and the result, all the story has been x and direction found to be passed, and this is the results. And this is the result in x direction, and this is y directions. And the drift, what the drift standard means that, and you can show the drift diagram, unit drift diagram from the ETABS, and take the screenshot and put here in the presentations. And this is the result after checking 0. Check the drift percentage is less than 0.4%. Okay, the x direction and y direction is also okay. That's the result. And after that we have to details design of structures on the topic, including the sample calculations of like design of slab, beam. You have designed all the slab, beam, column, staircase, leaf, basement, one, and foundations. Here you can include only the, you should not have to discuss the whole design of the slab. Here you can only include the results, like slab, what types of slab, there are two types of slab, and what kind of formula you have used, mx, my, what is the specifications, the minimum spacing, maximum spacing, reinforcements requirement, minimum maximums you can write here. Is for this all are from the export code. And after the final result of your and the design of slab, you have got the results. The main bar of the 10 diameters at the rate 300 center to centers, and the distribution bar 10 dia at the rate 400 center to center. The bottom bar details of the first 13 floor, main bar. This is the main bar. This is the main bar, and this one is the distributions bar. These are the distributions bar. These are the main bar. Main bar are distribution from there to there, like this you have to discuss, and the distributions bar. This figure has been come from the AutoCAD. You have the structural drawing. You have to print it on the final reports. There you can take a screenshot from the ETABS and put here, and this data has been come from the calculations. And this is the top bar details, how you can, how you can plant it the top bar. There you can show, and the next one is the sections. These three things you have to be shown. The first one, the specifications of the slab. Second one, the bottom bar details, and the top bar details, and the sections. Where you include the top bar, bottom bar, and all the diameters and the spacings. You have discussions and the 0.1 L from the outer side, inner side 0.15 for the top bar, and the top bar and the 0.3 L. Like this, you have to discussions. And the next one, the staircase, the specifications. What the specification of a staircase? What the what the what the trade and riser usually assigned, and trade not be less than 200, riser not be less than. This is the criteria of the staircase, and the what angle you have to make, and how many width no flights you have used. 12, you should not exceed the 12 number of flights. Like this, you have to do this specification. You have read this staircase and the result. So the stair, what types of staircase you have included in the project, that like this quarter ton staircase. Your may be differ. And the flight 1, take the riser 3, trade 2, and flight 214, and total riser and trade. Here you can show, and also show the plan, the quarter ton staircase like this. Here, where is the, and the starting from here to here like this, and we have discussed the width is it, and also the sections. These are the sections of the section on x-axis. Section on x-axis you have to show, and here you can discuss the main bar in the taken like this, the distribution bar of the diameter, this 10, and the two wells, and the length here, and the development length you have to discuss here. And the next, the section y, that you can discuss like this is xy, and the y is similar to the x. And the next is beam. There are the three types of beam. You have to represent all the types of beam. The one, here the primary beam, the envelope diagram, the criteria of the obtained the B58. The B58 is the name of the beam, unique name of the beam from the ETABS. You have to be checked. And the reinforcement of the left end, right end, mid, what kind of bar you have used in the middle, left side, right side, and the two-legged. Shear reinforcement has been passed, vertical stirrups you have added, and the spacings we have discussed like here. And these are all the discussions on the figures. What the left side 216C, and the D, and the in the middles 216, at the at the mid, at the right end we have it 222, 220, 220, and the spacing like this. We have to discuss on the PPT elevations and the sections, elevation and the intersections, and the secondary beam, which beam has been selected, beam name, unit name, and the left side number of bar, number of left, middle, right, and the stirrups in the left, right, and middles. In vertical stirrup has been present, and also show the figures and the discuss in the here. The development length I have taken the 466 like this, and the here and the right hand 216, and the middle 214, and the right hand 214, and the shears 8 mm, and then the shear reinforcement 8 mm dia, 8 mm dia at the rate 60 mm at the right in, at the left in 8 mm 60, at the middle 8 mm 130 mm, and the section 8A, section 8A, and section 8A, and section 8B. And this is the primary and secondary intersections. You can also show the intersections and the sections on y sections, the y sections, and T sections. This is the T sections of the Johnson. And the lift beam you have which is the beam you have selected, and the left reinforcement of the left, middle, right, and the shear reinforcement the left, middle, right, and the vertical stirrup also include. And there the lift beam elevations and the sections you have to present. And this is the general lab section is for the code you have to present here, because LD middle joint is the greater than LD. This was taken, the joint as lapse was taken in the L3 L by 3 from the left side or the right side like this. You have talked like this. And the second topic is the design of basement shear wall. What basement shear wall? what the result, what the data you have taken while calculating the basement shear design of basement shear wall, and what the result has been came like this: the concrete M25 steel AP 500 U, clear height of the shear are is 3.76 meter, say bearing capacity 200 kilonewton from the, the bearing capacity has been calculated as per the land in Ka active pressures. Like this you have calculated in the designs, you have all the put the data here, overall depth, and the final result 60 dia at the rate 130 in the center main steel, and the horizontal 10 dia at the 100 in the x directions. And we have to show them AutoCAD drawing. Here the column, here the shear wall, and here shear wall sections, shear wall top view elevations, and this is the sections you have selected. And you can show here like the 16 dia at the rate 133, and 10 dia at the rate in the column. Here you can select it like this, like we will discuss like this. And the second next one is column. We have to see the column definitions and the what the code said about the columns. Like this all the value has been taken from the codes. You can also go through the codes. And the second, the design of column. While designing the columns, the length of the column, size, clear covers, confining details, diagram, diameters of the diameter of bar, confining link diameters, and this MUMEX as you had calculated on the upper basement, ground floor, and the first floor. Like this, and after the result, you have get the six-legged stereo on the six-legged 10 dia, the red mid and confined zone from the and this is the columns column while confining the uh, bar. This is the this in the horizontal, but you should not have to present in the horizontal. You have put in the vertical way. This is showing in the horizontal way, but you can present the verticals. Okay, the joint, they are showing the joint, and the each and every, and there is the sections at the C, and the section at the D, section at E of and I, and the concrete column typical elevations. This is the elevations, typical elevations, and the concrete types and the typical elevations in the upper sections. And the second next one is the lift wall, the lift wall, the here you can include the total length, seismic load. You have calculated while calculating the while designing this lift wall, and there you can got the length, seismic shear wall, say base shear, calculate load, and all the these and the data. The final result is 20 and die at the report and the spacing provided on the both faces of the wall, like this. And here is the architecture AutoCAD drawing, structure AutoCAD drawing, where you represent the horizontal bar in the 20 dia and 20 dia 130, and the vertical bar in the two cases lift, and the sections 80xx, and the including the dia these and these. The next one is mat foundations. Of the mat foundation, designing of mat foundations. Here you got the result. Here you can use the shape bearing capacity 200, and the factor load you have gate service load, AST max, diameter of the bar spacing, and development length you have get after the designing of mat foundations. Here is the result of the mat foundations. The structure drawing, how you can plant the main bar and distribution bar in the mat foundations, and the sections, section 8xx, section 8x, xx, the verticals in section 8 in the xx section. And this is the zoom view of this at the A point. This is the in the shorter direction, the zoom view, how you can plant at the 20 die at the rate 115. This is the chain, linked chain to support the upper bar and the lower bar chain. Okay, next one, the longer directions. This kind of data you have to plant it the structure. And the last, you have to add the conclusions to your project. Like the on the project faces the various problem, what kind of problem you faces, what you learn from the project, what kind of software you use, and provided much useful, and the career that like this great work to minimize the error. What can you do to great work to to minimize the error, and manual calculations of interview job, and AutoCAD. You have what you have learned AutoCAD ETABS. Like this you have to present in the conclusions. Okay, and last, thank you for watching. these videos and hope this video helpful for you to make your presentation in the final year. And here the lots of check and the um, calculations has been in my channels, and also I will put in the all the links related to this above calculations and the check and the lots of design calculations link has been put in the description. Thank you for watching this video.